Good day, everyone, and I am here again to present to you the next topic that we need to discuss. So, for this time, we will have the limiting and the excess reactants. So, as part of the stoichiometric problems that we had last time. So, um, let us first differentiate the limiting reactant and excess reactant. When we say limiting reactant, so this is the kind of reactant which is completely used in a chemical reaction. Meaning to say it is nothing is left behind, or there is no leftover after the chemical reaction. So that is a limiting reactant. And on the other hand, excess reactant is a kind of reactant which has trace amounts that didn't react completely or is not completely used in the reaction. Meaning to say there is something left behind or left over after the chemical reaction. So not all of the amount, or not all of the certain amount that is there reacted with the other reactant. So the relative amount of reactants and products represented in a balanced chemical equation are often referred to as stoichiometric amounts. So the things that we are solving, the values that we are calculating, so that is referred to as stoichiometric amounts. So we are basing those amounts on the balanced chemical equation, because without the balanced chemical equation, we will not be able to determine the correct stoichiometric amounts of the reactants. Okay, so all the exercises that we had, this involved stoichiometric amounts of reactants. So mole to mole conversions, mass to mole, and mass to mass conversions. So those are the stoichiometric amounts of reactants. And for this topic, you will be applying those knowledge. Okay, so for example, when calculating the amount of product generated from a given amount of reactant, it was assumed that any other reactants required are available in stoichiometric amounts. So, if you are going to use a certain amount of reactant, how many or what is the amount of the other reactant that will react with it? So that is the stoichiometric amount. And that is the thing that we need to discuss here in limiting and excess reactant. We need to determine which among the following are the limiting and the excess reactant. Let us have this example or this analogy. For example, in making a sandwich, we need 2 slices of bread and a slice of cheese. And that makes a sandwich. So we have a ratio of 2:1, or 2 slices of bread is to 1 slice of cheese. Let us say that we have 28 slices of bread and 11 slices of cheese. So given this ingredients, how many sandwiches can we make out of these ingredients? So after making the sandwich, so we have 11 sandwiches and we have 6 slices of bread left over. Meaning to say, every piece of the cheese is used. On the other hand, there is something left over in our bread. Meaning to say, our cheese is our limiting reactant and the bread is our excess reactant because there is something left over. So that is the concept behind the limiting and excess reactant. So this is a simple analogy, a simple but a very understandable analogy of the limiting and excess reactant. So determining the limiting and excess reactant. So how are we going to determine the excess and limiting reactant? So actually, there are 2 ways in determining the excess and limiting reactants, and this is quite confusing. So I hope you really listen, or you have to watch and take every step, or remember every step to be used in this lesson. So there are two ways. First way is by using the amount given and solving for the amount of product that will be produced. So the given which will yield less amount is the limiting reactant. On the other hand, the one which will yield more amount or more product will be the excess reactant. So we will be using both of the given. So both of the reactants that is involved in the reaction, we are going to compare it with we are going to solve it by using by comparing the reactant and the product. So we will be using the both reactants. Then whichever of the answer is lesser, so that is the limiting reactant, and whichever of the answers is higher, then that is the excess reactant. The second way is by calculating the relative amounts that will react. So we will be comparing both of the reactants. So through this, the theoretical amount or actual amounts, the theoretical and the actual amounts of reactants can be compared. Okay, so those are the two ways on how we are going to determine the excess and limiting reactants. And I will be showing you both of the ways, so that whichever is easier on your part, you can use it. So as long as the answer is correct, so there is no problem on which way you're going to use. Okay, so let us have the sample problem number 1. So silicon nitride is a very hard, high temperature resistant ceramic used as a component of turbine blades in jet engines. It is prepared according to the following equation. So this is the chemical reaction and how to make silicon nitride. So 3 silicon atom added to 2 molecules of nitrogen gas produces 1 molecule of silicon nitride. So this is our chemical equation, or our balanced chemical equation. So this is the question. Which is the limiting reactant when 2 grams of silicon and 1.5 grams of nitrogen gas react? So that's a problem, and that is the given that we will be focusing on. So let us have the first solution, the first way. So our balanced chemical equation is shown here in the presentation. 3Si plus 2N2 produces Si3 and 4. So we will be using this chemical equation for mole ratio, for mole ratio. Then our given are 2 grams of silicon and 1.5 grams of nitrogen. So as I mentioned earlier, in the first way, we need to compare the answers or compare the products that will be yield in after the chemical reaction of both of the reactants. So let us compute the amount of product expected for complete reaction of each of the provided reactants. For the first reactant, let us find the number of moles of silicon nitride if we are going to use 2 grams of silicon. Okay. So if we are going to use 2 grams of silicon, so we need to determine first its smaller mass, so that we can convert it into moles of Si3 and 4. As I told you earlier, so this is just the application of what we had discussed last time. So we are going to use stoichiometric conversions here. So our involved in the first problem is silicon and silicon nitride. So first, we need to determine the molar mass of silicon. If you're going to look at the molar mass of silicon, that is 28.09 grams per mole. So in order to cancel grams of silicon, we are going to put gram of silicon below. Then on top, we have 1 mole of silicon. So now we can cancel the unit of GSI or gram silicon. Now our unit is cancelled. We have moles of silicon as the remaining unit. But we need to have the unit mole of silicon nitride. So the next thing to do is we need to determine the mole ratio. And what is the mole ratio there? So the mole ratio of silicon to silicon nitride is 1:2, 1:3, or 3:1. So we need to cancel mole of Si. So mole of Si should be at the bottom. So that will be 1 mole of Si 3 and 4 over 3 mole Si. So that will be the mole ratio. Again, this second part is the mole ratio of silicon to silicon nitride. Okay, so now we can cancel mole of Si. And now we have the unit that we are looking for, mole of Si 3 and 4. So now we can proceed to our calculation. So you just need to use your calculator and press 2 times 1 over 28.09 times 1 over 3. And we will arrive at the answer 0.024 mole of Si3 and 4. So that is our answer for the first part. Now, let us try to use the other reactant. Let us try to use 1.5 grams of nitrogen gas. So again, we will be looking for mole of Si3 and 4. So we're going to compare those two. So are we given 1.5 gram of N2 times? So we will be using the molar mass of nitrogen gas. So that's N2, so that's 14.01 times 2. And that will be 28.02. So that will be 1.5 grams of N2 times 1 mole of N2 over 28.02 grams of N2. Again, this part is the molar mass of nitrogen gas. Now we can cancel the gram N2. Let us proceed to the next part, which is the mole ratio. Mole ratio of nitrogen gas and silicon nitride. So that is 1 mole of silicon nitride is over 2 moles of nitrogen gas. Let us cancel mole of nitrogen gas so that we will arrive at the unit mole Si3 and 4. Now we have the unit that we are looking for. We can now proceed to our solution or to our calculation. So 1.5 times 1 over 28.02 times 1 divided by 2. And we will arrive at the answer 0.027 mole Si3 and 4. If you're going to compare these two answers, one is higher and one is lower. If we're going to use 2 grams of silicon, we will arrive at a lesser answer or lesser amount of the product that we are looking for. If we're going to use 1.5 grams of nitrogen gas, we will arrive at a greater amount of product or a greater amount of the silicon nitride. So, based from our solution, 2 grams of silicon will yield lesser amount or lesser product than 1.5 grams of nitrogen gas. Therefore, silicon is our limiting reactant and nitrogen gas is our excess reactant. So by just comparing the answers, silicon, we have smaller answer, nitrogen, we have greater answer. So silicon is our limiting reactant, nitrogen is our excess reactant. So that's it. Then for our solution number 2, so again, we have this balanced chemical equation and we also have this given, but we will have a different approach. So we are going to compute the amount of the other reactant if one of the reactants will be used completely. So on the first solution, we compared each reactants to the product. Now we are going to compare both of the reactants. So this part requires a longer solution. So just like the mass-to-mass conversion. So we will be looking for the mass of nitrogen. So let us try to use, or we are going to solve for the mass of nitrogen that will react completely with the available amount of silicon. So our available amount of silicon is 2 grams. And we need to look for the mass of nitrogen. So 2 grams of silicon, we need to cancel the unit of grams, so we will be using the molar mass. So the molar mass of silicon, again, is 28.09 grams per mole of silicon. So that's 1 mole of silicon over 28.09 grams of silicon. Cancel the unit. Then, we will be using the mole ratio of silicon to nitrogen gas. And that is 2 moles of nitrogen gas over 3 moles of silicon. We can now cancel the unit of silicon or mole silicon. Then, the last part, since we are looking for the mass of nitrogen gas, we will be using the molar mass of the nitrogen gas. So, what we need to do here is to put the molar mass. So, we need to cancel mole N2. So, mole N2 unit must be placed below. So, 28.02 grams of nitrogen gas over 1 mole of nitrogen gas. Now, we can cancel mole N2. And now, we can start our solution. Or we can start our, we can just use our calculator in our solution. So, that's 2 grams times 1 divided by 28.09 times 2 divided by 3 times 28.02 divided by 1. And our answer is 1.33 grams of nitrogen gas. Okay, so that's our answer. That's the amount of nitrogen gas needed to react with 2 grams of silicon. And what have you noticed? This amount, 1.33 grams of nitrogen gas, is the amount that will react completely with 2 grams of silicon. This is the amount needed. But we have 1.5 grams of nitrogen gas. So what does that mean? That simply means that from the result, we can see that if we use 2 grams of silicon, only 1.3 grams of nitrogen is needed. Thus, silicon is the limiting reactant and nitrogen gas is the excess reactant. So, it is very clear that if we're going to use 2 grams of silicon, some of nitrogen gas will not be used. Because if we're going to compare, what is needed is 1.33 grams and what we have is 1.5 grams of nitrogen. So, our excess is nitrogen and our limiting is silicon. I hope you understand that part.